Good evening all. Today we will discuss about high-risk pantograph. It is a modified and latest version of pneumatic pantograph with some special features like MED, ADD and some balancing and all. So we will go to detail. Nowadays the population is getting increased day by day. We are changing most of the conventional type pantographs to this latest version. So this model is LX3600. This 3600 means the maximum possible height. For that, we have an MDD that we will explain later. Okay. So the main specialization or the advantage in this pantograph is air cushion, and bellow concept. This make this pantograph unique and many features also added because of this working principle. We'll go in detail. So this main two advanced features, safety features in this pantograph which are ADD, it's called auto drop device, and MED, maximum extension device. These two already incorporated in the pantograph for the safety. So we will go in detail, and we have a control unit also for controlling this supply pressure. So these are the technical parameters like voltage is normal as because we are using the existing system, and whereas maximum speed we can use this pando up to 180 kmph. And mounting as conventional loco, there are 4 insulators, and static force is 60 to 110, and time we can adjust pricing 6 to 15 seconds. All these parameters we are maintaining now with compared to the conventional panel because we are using in the conventional system. But if any modification like high speed or some other parameters extension also possible in this panel. Temperature also 25 to 70, and the operating principle, that is something specialty in this panel, which is air bellow and gravity. So air bellow for rising and the gravity is for lowering. We will go in detail. And the weight is around 260 kg. So this maximum extension, this is the main feature of 3600 So when the variant is changed, this extension may be changed. We have one more version. So this one is maximum extension is 3600. We will go next. Okay. These are a overall structure of this pando in which there is a nameplate which show the firm name. Now we are using it heavily only. So in future there may become more, and part number, serial number. All the basic data of specific pantograph will be mentioned in this area. Okay. Huh? Okay. Now we will go to mounting details. As the conventional method, we have two pantograph in the roof, both sides, and this is the physical arrangement of this pantograph. Whereas there are 4 main bolts are there, 16 into 50 size, which is supporting on the insulator. These are a pictorial, a photograph of this window. This air pipe we can see, which is the supply air from the uh, bottom of the roof. There is a control unit also that will be shown. 4 insulators, and this pipe will continue the pressure till this area. Okay. Now, this is the control system arrangement, control unit for controlling the air supply. So first we will give the air in this area in which they inline, whereas it will go to a filter to clear the air, like dust and all particles will be cleared by this filter. And we can see 2 knobs. These both knobs are time adjustment. This one is for rising time, whereas this one is lowering time. So during overhauling time or schedule time, when the time is vary, we can adjust by rotating this knob. So one direction rotation will increase the time, whereas other will decrease. Similarly, lowering also. In conventional bando, it is not so easy to adjust the lowering time. Rising time. So here it is both are possible. That is one more advantage. And here we have provided a pressure gauge, which will we can see the output pressure, and then it will go a safety valve. So for the excess pressure, safety from the excess pressure. So this will go to the pipe to the roof, which we earlier seen that pipe is connected. So directly go to the fan. And this is the schematic arrangement. This area is we already see the same one. Supply air is coming. This is a rising arrangement, or this is lowering arrangement. And the center there is a valve. Then we will directly going this pressure to the air pipe. It's going to the pan. And two special features like ADD and MED. These are mounted on the pando itself and it is placed over. This is the schematic arrangement only. It's not actual, it's schematic. So it's both are there in the pando itself. A small device that we will see next. Then we will go to the parts. Okay. See, these are the parts of the panorama. As we said, there is four insulators which is mounted on the frame. Then there is a balancing arrangement, you will see, with a chain for rising. And as usual, there is a upper articulation part and lower articulation part, and some lower arm rod assembly, and this upper arm rod assembly, and this is lower arm rod assembly. This is the total construction. And as conventional loco, there are struts and all, and pneumatic air pipe also will be there in this case. So this is the collector head. Compared to conventional loco, this pando variation is we have air will go inside this strip area, the pan area. So actually this air, supply air, whichever we are giving, fully displayed in the distributed in the pando itself. The main advantage of that, whenever any entanglement, any accident or something happen, any irregularity, whatever it is, the air may leak. When any physical damage or physical inshapedness will happen, air may leak. That will go to activation of our safety devices like MED and ADD. That will go later. So this is the standard dimension of collector head. The length is maximum 1030, 1 meter, 1.03 meter, and whereas height is 316 mm. And the plus or minus tolerance also given. So these are the detail of collector head. Strip are there, showing shaft, and spring mounted and bearings are there. Bearings are there in this area for the fuel and the cushioning action of the total assembly. Two carbon strips as usual, metallized carbon. This is our device, ADD, automatic dropping device. Actually, it is showing where it is located. So this ADD is located in this area, whereas this is the balancing system for lowering. And MED also we have, which is placed in this area. These both are very small devices. So this is the schematic arrangement of how this both safety are working. So we can see the D4, that is 3.6 meter, which shows when the pando reaches 3. See, the D3 is our normal maximum working height in normal case, in healthy case. So when it's going beyond that limit and reaches 3600, 3.6 meter, this our ODD will act overhead. MED will act, maximum extension. So maximum extension is reached. So when it happen, when entanglement or accident or something happen, this all assembly may damaged and it may open to, it may happen 0.6 meter. At that time, this ODD will act, MED will act, and it will make the fan door lower suddenly. That will save further accidents or further damages or further uh, any possible issue. MED. The MED is for safety from max moving above maximum height, whereas ODD is for automatic dropping. In where this will happen, other than rising above, in position itself or normal working condition itself, something may happen. Like this pipe may have broken, some other. So all are working in the concept of pneumatic pressure only. Whenever the circuited air may leak, the loop may broken when the pressure will down. So when the pressure will down, it automatically will go down. So why? Because it is working on gravity, lowering on the principle of gravity. So this area is there is a weight actually. It's balancing weight. It's called balancing weight. So when there is no pressure, this weight will take to the pando lower, other than our spring concept in normal loco. And rising is giving there is a bellow. Jointly this with balancing weight there is one bellow. When we giving the pressure, this bellow will activate and it will make the pando rise. That is the basic concept. So this is ADD for automatic dropping for safety. Okay. Next we will go the maintenance plan. Right? Okay. So in our maintenance, different schedules are available in both different schedules. What we have to consider. Mainly, we can see uh, end top lubrication and replacement such in-depth activities. We are dealing in overalls only or ICs only. Whereas the basic inspection, visual checkup or time checking, that all happening in the normal schedule. Uh, mm, what the conclusion is, this Vando is maintenance free, very and as there is a safety to additional features, this will be add-on safety for our service system. Further, this is the see like replacement of bellows and damper pipe assembly. These all things happens in overall assembly. So minor things are very in minor schedules. We have to see very less activity. So in overall, these parameters and performance is very good. Thank you.